Hello class. In lesson 2.2, you're going to learn how to find the maximum and minimum value of a quadratic function. Now, the maximum and minimum value of a quadratic function is going to occur either at the highest max or the lowest min place on the quadratic. Now, because the quadratic is in the shape of a parabola, again, something that is symmetrical through an axis of symmetry, that maximum and minimum value is going to occur at the vertex of our parabola. So all we have to do in order to find the maximum or minimum value is determine where the vertex is. Now we have a maximum if the parabola is opening upwards, and that occurs when this value of a on our quadratic is a number that is greater than 0. If our parabola is opening downwards, like this one right here, then our vertex is our maximum value, and that occurs when our parabola, like I said, opens downwards, and that occurs when the value of a is a number less than 0. So let's look at some examples again from our previous lesson on graphing quadratics. If you recall from graphing quadratics, we have again the standard form of writing a quadratic is this vertex form, where f of x is equal to a times x minus h squared plus k. So again, our vertex form. Here, because the value of a is 2, that a positive 2, that means that our parabola is going to open upwards, and our vertex is going to be the lowest point here. So in this situation, f of x has a minimum let me spell it right. Has a minimum value. Well, where is that minimum value going to be located at? Well, that's located again at the vertex. And in this situation, our vertex is at positive 4, negative 7. Let's look at a second example. And there you go. Let's look at a second example. So on this example right here, again, since this is also in vertex form, and our value of a is a negative 1 specifically, that means that our parabola is going to open downwards. So our vertex is going to be up here, the highest point. So this function has a maximum value at the coordinate of negative 3, positive 2. So there you have it. Awesome. Now, it gets difficult now when the quadratic function is not in the standard form, and instead of it's in this polynomial form, ax squared plus bx plus c. But in order to find again the maximum or minimum, we still have to identify the vertex. And in order to do that, when our function is written in this format, is that we find it by first figuring out the x coordinate of our vertex by using this formula here, where we're getting the b value, dividing it by 2 times the a value, and then simply getting the opposite, multiplying it by a negative. Now this notation here, f of negative b divided by 2a, simply means that we're going to find the y coordinate of the vertex by simply substituting in this number into the values of x, and then determining what that value is. But again, just like the vertex form, our quadratic has a minimum value if this value of a is greater than 1, and a maximum value if the value of a is less than 1. So let's look at some examples. So on this example right here, since the value of a is negative, we know that this quadratic again is going to have a maximum. So our parabola is going to open downwards, and f of x has a max. Now, well, where's the location of this maximum value? Well, we have to figure out the vertex, in other words. We have to find out where that vertex is. So we do that by first figuring out the x coordinate of our vertex, which again is the h, by using this formula. So we get the negative value of b divided by 2a, where the value of a is going to be negative 1 and the value of b is positive 6. So substituting in that, we end up with this. So substituting in 6 and -1 into this formula for B and A, we end up with that. Now here we can just simply apply and use our handy dandy calculator here again to get this answer. Now this is again a simulation of the 84. You'll find again that the commands and some of the buttons are in the same places. So there's some new features here, but we won't use those anyways. So anyways, in order to get this fraction symbol right there, remember we hit the alpha, the green button, and then the y equals, and then, oops, the green button and the y equals, and this pop-up window is going to appear. On the 84, on your 84, you get to the letters n over d in the top option. You don't get the word fraction, you get the letters n over d. So we're going to select the first option, and this is going to appear again our fraction. I forgot to put the negative sign in the front, so let me move to the front, put the negative sign there, and we're going to put the value of b for 6, and in our denominator we're going to put in 2 times -1, and that value is 3. So our x coordinate is 3. Now to figure out the y coordinate of our function, all we do is simply plug in this number into our function for, let me hide this real quick, into our function for x. So since our function is -1 times x, we'll replace the x with 3, plus 6 times x, again replace the x with 3, and then minus 8. So all I'm doing again is replacing these x coordinates, these x values, these x variables with my value of 3. And now with our handy dandy calculator, we can figure out what this equals to. So we have -1 parentheses 3, put the square on the outside, plus 6 times 3 minus 8. That equals to a value of 1. So f of 3 is equal to 1, and that is our vertex. So our maximum is located at the coordinate point of 3, 1. And there's your answer. Awesome. Let's look at example number 4. Let's do another example where we find the minimum value. So in this example, since the quadratic again has a value of 1 for the value of a, that means that our parabola is going to open upwards, and we have a minimum value. So f of x has a minimum. And well, where is that minimum value located at? Well, we're going to find it by first figuring out the x coordinate of the vertex by getting -b divided by 2a, which here the b is -4 and the a value is 1. So let's plug this into our handy dandy calculator. So control y equals to get the fraction. Oh, let me put the negative in the front. And then we have -4 in the numerator, and in the denominator is 2 times +1, which equals 2. So x equals to 2. Now to figure out the y value, we simply now plug in, let me move out of the way. We're going to plug in that value into our function. So it would be 1, because it's 1x squared, so 1x squared minus 4 times 1, times 2. The x value we're plugging in is 2, and then plus 3. And with our handy dandy calculator here, you move over here. So with our handy dandy calculator here, we can figure this out. So we have, let me put in the 1, not necessary, but let me write it. So we have 2 squared minus 4 times 2, and then plus 3, and that's equal to -1. So when we plug in 2 into our function, the y value is -1. And that is the location of our minimum value. Awesome. Now, one of the applications to this is using again in the real world situation. Well, so while this is the coordinate for the vertex, the location of the vertex where the actual minimum value is located at, the actual minimum value is always the y coordinate. So we say that the minimum is at 2, and the minimum value is -1. That's the minimum value. So in a real world application, if I ask you to find the maximum or minimum value, as you'll see in some examples, I'm asking you to find out the y coordinate of the vertex. So for example, let's say that the height of a water balloon thrown off of a roof is given by this function h of t. We want to find the maximum height of the balloon. Well, first, I have to figure out where the maximum is occurring at. So we're going to start by first figuring out the x coordinate of our vertex. Since here the b value is 25 and the a value is -4.9, we're going to get the x coordinate of our vertex by, again, multiplying 2 with -49, dividing 25 by that answer, and then multiplying it by a negative, which again we can do all in one single step with our handy dandy calculator here. All right, so we have our negative sign in the front, and our numerator is positive 25, and then the denominator is 2 times -4.9. Now we get this crazy decimal value here, so let's convert this decimal into a fraction. So clicking on the math key, okay, that key right there, we're going to select the first option, fraction, and we're going to convert our answer into a fraction, which is 125 over 49. So that's the decimal value that we're going to use. So now, using that value, let me move this over here, we're going to plug in that value into our function for t. So h of 125 over 49. And let's see what that's going to give us. So we have -4.9 times 125 over 49 squared plus 25 times that exact same number, then plus 40. So let's write this in our calculator. So -4.9 parentheses. Instead of writing the number, I'm just going to simply click up using the arrow keys on the right side of the screen and hit enter, and it's going to copy it down. I'll close the parentheses and square it. I'm going to add then 25 parentheses, again click up to highlight again the 125 over 49, hit enter, and it's going to copy it for me, and then plus 40. And everything again that I'm doing here can also be done on the 84s and even on your decimals calculator. So here I hit enter and I get this number right there. So h of 125 over 49 is equal to 71.8. We'll estimate it to 8, which means again that this is your maximum height. And we're going to estimate this again to the nearest whole number. So we're going to say 72. So that is your max. The ball is going to reach a maximum height of 72 units, whether that's feet, meters, yards. That's not specified, but it's going to be a total of 72. Awesome. Let's look at example number 6. Let's do another example. So let's see. Let's look at example number 6. So here we have the revenue of a product sold by a company is given by this function where x represents the number of products sold. So what is the maximum revenue? So we'll start by first figuring out where the maximum is occurring. So we're going to figure out the x value of the max. The b value is 50, and the a value is negative 10. So let's break down our calculator. The negative sign in the front, I always forget to do that. I should always probably do that first instead of moving over. And then 2 times negative 10, that's 2.5. So our maximum is occurring at 2.5. Now to figure out what the actual maximum value is, I'm going to replace the value of x with 2.5. And this right here should be plus, not minus 500, plus 500. And now let's calculate that. So we have negative 10, 2.5 squared plus 50 times 2.5, and then plus 500. And that's equal to a total of 562.50. And this one, we're not going to estimate it. This again to the nearest dollar. So this is the amount. This is our max. $562.50. That's the max amount of money they can sell for selling 2.5 items. Anything lower than that or higher than that, if they sold 2 or 3 items, then the amount of money that they would make would be less than that. So they want to sell exactly 2.5 of these items. Okay, let's look at another example. Let's look at example number 7 here. So in example 7, the shape of a bridge is modeled by this equation where x is the distance from the left of the bridge and y is the height of the bridge in meters. So everything, the unit here is in meters. What is the maximum height of the bridge? So we'll start by first figuring out the location of the max. So x equals to negative b divided by 2a, which is negative 3 divided by 2 times negative 0.01. So alpha y equals, to get our fraction, 3 over 2 times, don't forget to put the negative sign in front of that fraction. I had to go back and move in the front and then put in that negative sign. And now we have in the denominator 2 times negative 0.01. Oh, no, it's 2 zeros and then a 1. Negative 0.001 there, which is equal to 1500. So now that we know where the max is being located, where the maximum height of the bridge is at 150 meters from the start of it, we're going to figure out what the actual height is by plugging it in to the values of x. So y equals negative 0.001 times 1500 squared plus 3 times 1500 minus 10. Oops, there we go. And there is your answer. So that's the max height. Now let's look at an example of finding minimum. And again, because these are real world applications, you won't have to worry about determining if it's a max or a minimum. That information should be given to you again within the question itself. So like right here, I want you to identify the minimum cost. Well, because it's a quadratic, I find the minimum at the vertex. The maximum and minimum values are again occurring at the vertex. So using the technique that we find to find the vertex is going to help me determine the minimum for this quadratic. So the value of B is 100 and the value of C is 0.005. So let's see what we end up with. So negative sign alpha y equals, select the first option, number 1, and we're going to put 100 in the numerator, move down, and then 0.005 in the denominator. And that is negative 10,000. Negative 10,000. Now let's evaluate this with the number negative 10,000. So that's with 4 zeros. Let me look real quickly. 0.05. All right. So 0.005 times negative 10,000 plus 100 times 10,000. And I ran out of space here. Plus 500. 5,000, sorry. 5,000. So 0.005. Instead of typing that entire number, I'm just going to click up and enter that number, copy and paste it there. Plus 100, parentheses, move up, copy and paste that number, and then add the 5,000. Which we get to be a total of negative 49,000, negative 495,000. So that's going to be our answer. That's the minimum cost for producing, again, X units of a specific item. And lastly, the last example here, another one of minimizing the cost of producing fixtures per day. So a manufacturer of lighting fixtures has a daily production cost of 0.25x squared minus 10x plus 800. So where C is the total cost and X is the number of units produced. So let's figure out what the minimum cost of producing an X number of fixtures per day. So let's first figure out how many they have to produce. So that would be X is equal to negative B divided by 2A. And since our B is negative 10, we have negative 10 in our denominator. We still have the negative sign right here in the front, but negative 10 in our numerator, not denominator, numerator, I misspoke, and 2 times 0.25. So let's see. So negative sign, alpha y equals, and we're going to type in negative 10, and then 2 parentheses 0.25, that's equal to 20. And now let's move over here, and to figure out what the actual minimum cost is, let's plug in that number in for X. And instead of doing this by hand, of course, we have our 84. So let's just plug it into our 84. So 0.25 parentheses 20 squared minus 10 parentheses 20, and then plus 800. That's equal to a total of $700. So it's going to cost them $700 to make 20 of these things per day. And that's going to be the minimum. So this is your minimum value. So your minimum value is going to be the $700. Well, that concludes the examples on lesson 2.2. If you have any questions, again, send me a message on Remind or through email. And I appreciate you watching, and I hope you have a great day. Goodbye.